Hello, everyone, and good day. My name is James Mancini, and I'm one of the original founders of Netreo. Today, we're going to be using a very slightly different format for this presentation by addressing your questions as we go along. So please, if you have any questions, enter them into the questions section of the GoToWebinar interface, and we'll stop to answer them at key points during the presentation. So some of the most common pain points in network management that we hear customers talking about are over alerting or getting way too many notifications. So this can cause engineers to tune out potentially critical messages, and it really trains them to filter or ignore alerts as they're coming in, which leads to larger and longer outages, as well as more repeat outages. Too much admin overhead. I mean, it's great if you have everything under control and being monitored, but for many organizations, they never really get there. The environment has changed before they even finish implementing the monitoring for what it used to look like, and this becomes an endlessly repeating cycle where they're always behind the curve and they never really have the time to get everything monitored correctly. Both of these are related to the third issue, which is spending too much time fighting fires instead of preventing them. So, I mean, it's great if your monitoring platform can notify you when a server is down or when it's having a serious issue, but wouldn't it be a lot better if it could let you know before there was a problem that was affecting the users? So today we're going to cover 5 easy ways you can improve and simplify your network and systems monitoring, and I'll be showing you some live examples of how we accomplish them using our OmniCenter platform. The first key is to track your network baselines. The idea here is to detect unusual behavior instead of just alerting when a failure occurs. Almost any monitoring system will allow you to create static thresholds and monitors that will alert when there's a failure. But once that happens, you have to scramble to restore service, and that means impacted users, making rush changes, and those can introduce new problems. So getting to see in advance when something is acting unusual instead of just alerting when it fails is a great way to get ahead of the firefighting curve. So if you set an alert saying that your Java-based client tracking system is suddenly using 50% more memory than is typical for this time of day on this day of the week, that gives you a way to investigate what's going on and potentially fix it before the application actually fails and you have a bunch of angry users calling the help desk. Once you've got a baseline set of data, you can start looking at long-term trends as well, using automated reporting to make sure that nothing gets missed. So for example, getting an email every morning showing you which systems had an unusual amount of CPU yesterday, or what storage arrays may have suddenly jumped in utilization. The reason most companies don't get to this point, however, is that trying to create and tune a performance baseline, even for a single system, can be very time consuming, to say nothing of doing it for hundreds or thousands of systems, applications, and network devices, and then trying to keep up with it as new applications are deployed or business processes change. So even a large company with a dedicated staff to do this is going to have trouble unless they have some way of automating it, and we'll show you how we address that problem. The technology we use to make this process simple and automatic is called anomaly detection. So we're constantly logging performance telemetry for all the monitored devices and applications, including metrics like the number of log messages received and the CPU and memory utilization of each process running on the system. And then OmniCenter automatically generates a baseline behavior model using the historical data we retain. For most statistics, that's 100 days of high resolution data, and then automatically adapt the baseline as the environment changes and evolves. So we then compare what's happening right now with what is normal for this time of day on this day of the week, or even hour by hour. And you can set the sensitivity of the detection to high, medium, or low, depending on your tolerances and your environment specific settings and what the usual range of that statistic is, so you can fine tune this process. That information is then used to detect when something unusual is happening, so we can flag that as an anomaly, and that can generate alerts or show up in reports. So this allows you to find unexpected impacts. For example, one customer of ours discovered an issue because normally at 10 a.m. on a Wednesday, the database server was running at 50 or 60%. But today it was running at 15%, and it turns out that a minor bug fix that got pushed to production the day before had put the wrong API key and broken a form deep within the application where the web team didn't notice it, and customers weren't able to complete the orders properly. Now, a change like that, a sudden drop in CPU usage, is the kind of unusual behavior that would never trigger a static threshold, but in this case revealed the problem long before they noticed the drop in orders and the lost customers that would have resulted. You can also use this to track things like log messages for a specific problem. So for example, looking at the volume of login failure messages might be very informative if the average number of failures per hour suddenly jumps from 10 to 100. The next key point is to make sure that you're alerting the right people at the right time. And this sounds obvious, but you'd be surprised how often it doesn't happen. If you're not going to react to a notification as soon as it comes in, you shouldn't be alerting on it. For example, if you're getting alerts when hard drives reach 90% utilization and then just ignoring them because it's not urgent yet, two things will happen there. First, sooner or later, you're going to get an application failure because you forgot to circle back on that alert before the drive filled up. And second, you're conditioning yourself and your teams to ignore those alerts. And someone someday will inevitably ignore the wrong one, and you're going to have a major outage on your hands. Instead, use reports so that you can be kept up to date on things that may not need to get folks out of bed, but you can still stay informed with. A nice email in the morning showing you which printers have low toner is a lot nicer than being alerted on it every time it happens, and you can schedule the replacements for non-intrusive times to prevent interruptions of service. A key success factor, though, is to make sure that these reports are scheduled and automated so that nothing gets missed and you're not depending on some poor soul to take time every week to run and send it. A task that's sure to get skipped when the team is up to their necks in alligators or when the designated engineer is out on vacation and the person covering for him has no idea how to work the reporting software. So when we say actionable alerts, what do we actually mean? Let's look at a couple of examples to see what really is actionable. So if I get a high CPU utilization alarm, is that an actionable alert? Well, it might be if the CPU has been stuck there for a while. So in our software, we allow you to set a delay for these types of alerts, so it doesn't generate an alarm until it's been, over a threshold for a particular length of time. The CPU on a SQL server is going to peg 15 times a day. I don't need to know about that. What I do need to know is if it stays there for 15 minutes, because it probably means I have a job stuck that I need to go shut down and investigate. So, that's an example of an alert that's going to generate an immediate response as opposed to one that's just informational, which really should just get sent as a report instead. Now, what about if a switch port goes down? So is that actionable? Well, if it's plugged into something important, generally yes. So this is a good candidate for an immediate alarm. But what if it's part of a port channel or if it's just one server in a cluster? That might warrant a different priority or a different method of notification that doesn't require a drop everything and fix this kind of response. Or how about the public website going down? Well, that's generally a big yes, but you want to make sure that it's down from outside the environment as well as inside. So using things like application checks launched from multiple remote locations can help you assess the seriousness of the issue. With OmniCenter, we make it easy to do that from anywhere, including your data center or from our reflectors in the cloud. We also build in a lot of tools to help you optimize these alerts, which will help you to identify what I like to call the noisy birds. So these are the few configured monitors that are responsible for a disproportionate amount of alerts, or those where an adjustment to the sensitivity of the alarm might be required. You can also use things like template baseline reports to see exactly which alerts are being generated by the configuration templates, so you can make changes then directly in the templates and have those automatically rolled out to all of the affected devices where that template is applied. You can also use other kinds of specialized reports like notification summaries to see exactly what alarms are going out and get a count of how many alarms are coming from each device or each type of service check or threshold alarm to identify when you have a particular setting that is causing too many notifications. A really quick way to see results here is to leverage the tools to take advantage of things like automatic alert suppression and things like root cause detection. So by configuring a topology into your tools or letting the tool discover it, the tool can determine that the reason for all the remote devices at that location suddenly going down is because of a failure on the WAN router. Instead of sending out notifications for every remote device separately, every switch, every server, every application, wireless access point, all the stuff at that location, I can instead get a single alert that tells you right away the problem is the WAN router. Another great way to get control of the alerting is to integrate automation, and automation comes in a few different flavors. So the first place to look is automating the response to alerts so we can hopefully eliminate the need to send notifications at all. You can link in commands, CLI commands like SSH or PowerShell, or API commands like webhooks, so that your monitoring system can restart ports, relaunch applications, even dump real-time diagnostics in response to an issue. However, a lot of customers tell us that they're uncomfortable with automatically executing commands. So our system allows you to control these commands manually through operator intervention if you prefer. So if you want to add a click to restart server function directly into the web interface, but limit access to just the administrators, we give you an easy way to do that. One example of how a customer used this is they set our system up to restart the server automatically after hours, but during the daytime when the NOC is there, only notify the NOC. So let the operator make the decision as to whether or not to restart the service when they're available to do that. However, one key point to keep in mind when you're automating this kind of response is that maintenance windows become absolutely critical. Otherwise, a scheduled software upgrade is not going to go like you expect because the monitoring system is going to be taking action in the background. And nothing is more frustrating than shutting down the application to install the software update and then having the server suddenly reboot on you. One of the best practice recommendations that we often give to customers is to use distribution lists instead of individual emails for email alerts and for automated reporting. And there's a few good reasons to do this, but one of the key ones is to better keep in sync with personnel changes. There have been more than a few incidents where a problem was detected by the monitoring system, but the alert went out to an abandoned or invalid mailbox. And this caused a significant delay in detecting and acting on the problem. It can also allow you to create an easy historical archive of automated reports and share them in a central location. So if you need to go back to the weekly performance reports from 2 years ago in September, they're easy to find and locate, even if the detail data has been archived by now. And that can also be important for compliance purposes. You also want to make sure that the techs and engineers are acknowledging problems as they're dealt with. So a monitoring screen that is flooded with alerts makes it very easy to miss new critical problems. And they need to be acted upon and acknowledged or corrected as soon as possible. So we generally say as a best practice, it's not acceptable to let alerts sit there until the team's regular working hours. If it isn't a problem during off hours, the alert should only be generated when it is a problem and when someone is available to work on it. And any alerts that don't get addressed within a specific time frame should get escalated. Using maintenance windows for the planned outages not only helps to reduce the volume of alerts, but it also normalizes uptime reports so that systems that don't have any unplanned outages in a given time period will show 100% uptime without having to manually adjust the reports or write explanations in order to roll them up to senior management. And we've said this once already, but don't ignore the alerts. Ignoring alerts is a sure way of getting into trouble. At some point, the mistake is going to be made and someone's going to ignore the wrong alert. So the best thing to do is to avoid the problem altogether by making sure that non-actionable alerts are never even seen. Now I'm going to take just a minute here to show you what we've been talking about before we move on to kind of demonstrate the concepts as well as the specific methods that we use to achieve them. So one of the things that we talked about was tracking network baselines. So one of the keys to doing that is the anomaly detection like we talked about, so we can automatically build and analyze those baselines over time. And you can see here on the demonstration system that I'm using, I've got several anomalies that have already been detected. We've got them set up on this system so they specifically are flagging plenty of different anomalies over time. So there's always interesting things to look at. But I can really go into any one of the systems or statistics that I'm monitoring, and I can configure to watch that system for specific unusual behavior. So for example, if I go into a system and I edit, the threshold settings for any of the different statistics that we're monitoring, on those statistics, I've got the ability to fine tune exactly how those anomalies are detected. So if I want to go in here, for example, and look at CPU utilization for my HTTP process, I can add that in. I can decide who, if anyone, should get notified, and if no one's getting notified, you still use that information in reports. But then I can take that data and define an anomaly for it. So I can say whether I want to get alerted on higher than normal, lower than normal, or both, and then define a sensitivity. So I can define a warning sensitivity as well as a critical sensitivity. So I can say if this particular system is behaving the same way it did on this day last week at this time last week, it's going to generate an anomaly based on it deviating a certain amount from the previous baseline. And those baselines are built out over the last 8 periods. So in this case, it's looking over the last 8 weeks for what's normal on a Tuesday at this time of day for this particular system. I can also set a minimum value, which is a cutoff that prevents anomalies from being detected. So for example, if I've got a CPU anomaly here and it jumps from 1% to 2%, that's a big percentage change, but it's still a small enough value that I probably don't care about it. So I can set a cutoff for that anomaly at say 15% and then save that so that now whenever the CPU on that particular process is monitored, it'll look for that historical baseline behavior. And if I've got historical data for the system, as soon as I turn anomaly detection on, it'll start working because we've already been saving all of that detailed telemetry data for those systems over time. So that gives me a way to kind of immediately see results from that. I can also go in and kind of tweak the way that those notifications are sent. So in OmniCenter, we use what we call actions to send out notifications, and those actions can be anything from email to SMS to SNMP traps, or even what we call active response type methods where we're calling a particular API to do things like open a ticket or execute a command on a particular system to reboot a server or restart a particular service. So those can all have different timeframes associated with them, and those timeframes are time of day and day of week. So this allows me to control when I've got something that is production hours only or is 7/24, I can control what kind of actions are going to be taken based on that and what time of day it's valid to take those actions. I can also see here whether or not I've manually enabled this function so that anyone who's going in and looking at a particular incident to try to fix a problem has the ability, if they have the permissions, to go in and execute that command on those particular devices. So if I go into, a system that's having a problem, I've got the ability to manually execute actions on them and say, in this case, I'm going to go ahead and, try to reboot this Windows server, acknowledge the problem when it does it, and it'll execute that command on the server, provided it can get there and that the authentication is working and I've got the permissions to do that. But it gives me a really easy way to kind of integrate that directly into the web interface without having to, manage a separate set of logins or, have multiple access control points for all of those different functions. Another great way that we talked about to find noisy alarms is with the template baseline report. So in OmniCenter, a lot of the configuration is through templates, and it's kind of the best practice to manage all of your configurations. We highly recommend this, and we'll talk more about templates shortly here. But if I go in and click the baseline reports for these templates, I can actually see immediately, which templates are responsible for most of the alarms in the system. And I can actually go in and see for this particular alarm, which configuration, in this case, service check for configuration is saved, has generated most of the alarms, as well as which thresholds have generated most of the alarms. So it gives me visibility into exactly where those alarms are coming from and where I might need to modify settings in order to improve my response and reduce the number of alarms that are coming out in the system. One of the other things that we talked about was the notification summary report, and this is another really useful way to find where those alarms are coming from. So I can go in here, for example, and say, for a particular group of devices over a particular time frame, let's say last 7 days, I want to summarize this by services description so I can see which services are generating the most alarms. And in this case, I know it's the configuration saved alerts, because it's generated 50 recoveries in the last 7 days. So this will allow you to discover if there's a particular service check or setting that's generating the majority of the alarms. You can also take this report and summarize by things like devices. So you can find out if there's 1 or 2 devices that are generating most of the alarms in the system and really narrow down to exactly what's causing those notifications to go out, which makes them very easy to tune and adjust away. So let's take just a moment and I'm going to go through and answer some of the questions that have come in so far. So first question, what are the database requirements to deploy OmniCenter? So that's a great question. OmniCenter is designed to be self-contained, so there's no separate database server. It's built in. Whether you're using a virtual appliance or a physical appliance, we're using a high performance version of a MySQL variant that's pre-built into the system. So it's designed to self-optimize and there's no database maintenance or licensing required to deploy it. One of the biggest things you can do to reduce the admin overhead of a system is to use templates to drive the configuration. So templates are used to drive the control of all of the different settings for a given device. So who to alarm and when, anomaly and threshold settings, which log messages you want to track, even things like what configuration lines we want to make sure to look for or to alert if they're not present or alert if they are present. All of that can be done through the templates themselves. And in OmniCenter, templates are applied by organizational elements. So they're usually controlled by things like device type, like Windows, or category, like web servers, for example. I can even do it by site or by applications. So in turn, all of those attributes that define which templates are applied can be driven onto those devices by auto configuration rules. So the rules drive the new devices directly into the categories, and the categories drive the templates that apply all the settings to the device. So any given device can have settings applied for many different templates, and then nothing ever gets missed. So I know that my SQL servers always have the right set of baseline Windows settings on them, but they also have settings that are based on the fact that it's running on a particular hardware platform or a particular virtualization platform. And then because it's running a particular application, I've got application-specific settings that I'll all layer on top of that via those templates as well. So that auto configuration system is a rule-based system, and it comes with a set of rules to kind of start you off. And you can easily customize or create new rules to fit your environment. So it uses these to set device attributes like category, site, application groups based on any device criteria. So that includes things like what processes are running and set to start, what ports are listening, what the device is named, where it's located, SNMP values like system description or location. And this makes sure that there's no manual step in the provisioning process. So the idea is that we can ensure the devices end up in the right reports with all the right settings applied, all the right alerting applied, regardless of how they get added into the tool. There's no manual checklist to go through. So these are automatically applied to devices as they're discovered or as they're pushed into the system via APIs or discovered via scanning or integration with other systems like cloud providers or vCenter, for example. But we can also make sure that those rules are reapplied as often as we want. So if we want to make sure everything stays configured exactly the way the rules say, we can enforce that on the devices. The templates are driven via these rules. And using all those criteria, we can dynamically apply all the different relevant templates. So settings from all the different templates will roll down onto the device in a cascade. So the idea is a SQL server coming online gets the basic Windows settings, gets the SQL specific settings, and then might even get some special settings applied like different latency thresholds due to geographic location. You can align those templates with the monitoring plan to make sure that they set the appropriate escalation timings and that they've got the right notifications built in. And you can even have those define things like escalation, authentication, and even which automated recovery actions you want to take. So the whole system is designed to be flexible enough to be able to accommodate global enterprise type customers, but still be simple enough for a small IT department to use without a lot of training or any dedicated personnel. So let me take just a moment and walk you through an example of how this works so I can show you how OmniCenter takes something that normally would be really complicated and make it very simple from an administrator perspective. So a new device comes online. And for the sake of argument, we're going to say that we discovered it via a discovery API like AWS or vCenter, although this process is the same no matter how the device gets added to OmniCenter. That new device is then passed off to the auto config process. And that's going to use the rules that we've established, like the name of the device, the process is running, to automatically put devices into the correct categories, application sites, groups, and then use those criteria to include it in automated reports and to define which templates you want to have apply to that device. Those templates in turn then drive all the other settings on the device, so authentication, alerting, thresholds, all that kind of stuff. And those settings are automatically applied to those new devices, which drives the behavior of the monitoring engine. The monitoring engine in turn drives the dashboards and custom views, as well as all of the different kinds of alerts, SMS, email, mobile app push, webhooks, ticketing integration, things like that. It also drives what we call active response, which allows you to automate those CLI command execution, PowerShell execution, or even pushing commands to APIs to do things like restart virtual machines or reload processes or even reset cloud servers if that's what you need. And all of this happens just by adding the device to the network. So again, there's no manual process involved to make all of this stuff work and to keep it in sync as the environment changes. Another big part of solving problems quickly and efficiently is to have enough information when you start. So we like to take the approach of monitoring every level of an application to make sure we have a comprehensive view of what's going on. So for example, monitoring systems and servers is important, but we need to be monitoring from multiple perspectives using multiple data sources and then correlating all of that data automatically instead of relying on multiple different silo platforms for information. Multiple platforms often have conflicting or different information, which then delays resolution and can cause finger pointing between teams. It can also lead to problems where a team's internal tool calls out a problem and they try to fix it without telling anyone, and then other teams start having new problems and have no idea where they may have come from. When we say monitoring on multiple levels, we're talking about not just watching all the component parts like the load balancing, web servers, middleware, databases, storage arrays, and firewalls, but also monitoring multiple components within each of those devices and application level testing as well. But to make it usable, we have to make it easy to understand. So when there's a crisis happening, there's some way of simplifying that view to help even non-technical people stay in the loop. And that's a key to making sure that this is really a successful approach. So what are some of the different perspectives that we can use to monitor an application? Well, of course, we can watch all the different devices involved. But we want to go deeper than that. So we can also do things like watching the system hardware, the operating system, and the process itself, get some internal information from the SQL server, for example. We can also, even within a single server though, watch at multiple levels. So for example, there's the difference between watching the overall CPU on a SQL server and watching the SQL process specific CPU usage. Once we have both pieces of data, we can determine when a problem is coming from our key application and when something else that's impacting it, like an antivirus update. And that's already going to save us some time in troubleshooting and solving the problem. But we can also watch the application itself from the outside. So we can validate that the whole thing is serving up pages and that the user response times and experiences are adequate. And then what we do is we take all of that telemetry and we merge it into a single strategic group that simplifies and shows you the status of the application in a easy to understand percentage score. So even non-technical stakeholders can see exactly what the state of a particular grouping is. And we can define those in any way that we want. You can even have multiple strategic groups for a single application if you want to have a separate one for, storage and SQL, and then another one for the e-commerce application that both of those depend on. I can nest those together, or I can have the same device in multiple strategic groups. It's designed to be very flexible. And there's tremendous utility in being able to do all of that from a single platform so we can get a single consolidated view into all of the different aspects of an application. And if we drive that configuration using rules and templates, this is all automated, so we're not adding a lot of admin burden to get to this point. The last item I want to discuss today is configuration control. So it's an unfortunate fact that many, and some surveys I've seen actually suggest most outages are the result of incorrect configuration changes. So monitoring when and how configurations happen is key to limiting the impact of those outages. It's also a requirement for many auditing and compliance programs like PCI, for example. So first, we want to make sure that we're getting notifications whenever a configuration is changed, especially on things like key network infrastructure devices. This allows us to make sure that the changes are compliant with the change control process and we're getting notified if there are any rogue or improvised fixes happening in the environment. We also want to be able to archive and compare configurations over time. And we suggest as a best practice that you make the time to review them. So going back through configuration changes monthly or quarterly to specifically identify the scope of all the changes that were actually made is often time well spent. Changes made during a crisis to fix a specific problem are highly likely to inject new defects into the systems. So a calm after the fact review is a really useful tool to prevent future outages. Also, if you can, you might want to centralize your configuration changes through a single platform for logging and control. This allows you to disable direct access to the system's command line and give you the best possible audit trail for post-mortem analysis and compliance reporting. So now I want to take just a couple more minutes and show you how those complex concepts are applied in Omni Center, and then we'll finish up with any remaining questions that you folks have. Please do be sure to enter those into the GoToWebinar interface so we know that they're waiting. Okay. So for the first thing I'm going to do is I'm going to go ahead and create a new template. I'm going to add a template here into the tool, and I'm going to make this template specifically for my web application. I can put in authentication credentials if I'd like that are specific to the devices this template's going to apply to, but in this case, I mainly want to use this so that I can go in and create some very specific settings that are unique to my web servers. For example, I might want to add a process check that says I want to make sure that I'm monitoring for the web service process itself. So I can go in here and look for a particular running process. And I can go in here and make sure that HTTPD is running, for example, and I can set how sensitive I want that to be, how long do I want to wait before notifying, and how often do I want to recheck before notifying. If I want to escalate that after a particular length of time, I can go in here and say, I want to make sure management gets notified about that after, if it's been down for 2 hours. So I'm going to build that into the alarm. And then I can go in here and I'm just going to call this web process and add that into my template. So now I've got a service check that's built into the template that's going to look for that specific process running. So when I apply this to my web servers, it'll automatically get that setting. And I can do this with other settings as well. So if I want to, for example, go in and create a specific threshold for logged messages or for CPU on a particular process or memory utilization on a particular process, I've got the flexibility to be able to go in and do that. So I can go and say, I want to look for utilization by process, and I'm going to go ahead and then pick that server and add a string. So it's going to match any HTTPD process for memory utilization. And then I'm going to set that up as an anomaly detection. So I'm going to look for an anomaly on that from day to day and week to week. And I'm going to go ahead and create that threshold. And that'll automatically be added into the template. Next, what I want to do is I want to make sure that this template is going to get applied to any of the different web servers I put in the tool. So I'm going to link that template into a specific category in this case. I'm going to go in and say, if my web servers category, I'm going to go ahead and edit that and set the template for that to my new web app template. And it's just as simple as that. Now, any devices that get added into that web servers category will have all of those settings applied to them. So now what I'm going to do is I'm going to make a rule using the auto configuration parameters that simply says that any system that's listening on a web port should get added into that particular category. So I can go in here and say, I'm going to add this as a web servers, and I'm going to say the criteria that I'm specifically looking for is going to be open port 443, and maybe I want to say it also needs to be running Linux. So I can go and say the device type for this unit is going to be Linux, and then I'm going to save that rule. I can then control what order these rules are executed in. So if I want to make that a more important rule, I can move it up the list and save that order. Now, anytime that system gets detected, if it's a Linux system running 443, it will automatically put it into the web servers category, and all of those template settings will get set for it. And I can do that with authentication credentials. I can do that with alerting settings. So I can make sure that all of that gets automated and configured correctly. I can also then include additional servers and types into that. So if I want to have this monitor my storage and database and load balancers, it's designed to be completely platform independent, and all of those can get merged together. So then I'm going to create that strategic group for them. So I'm going to go in here and I'm going to edit a strategic group. I can create a new strategic group or edit an existing one, and I can go in and say, for this strategic group, we're going to call this is my special web app group. I can set my thresholds for what is considered degraded or failed for that particular group, and then edit the devices that are present in that group. So if I want to make sure, for example, that all of my different web servers are in there, I can go in there, pick all of my different types of devices that might apply to it, filter this out to just my Linux servers, and add those into that strategic group. Now that'll start appearing on those dashboard pages. It'll appear on my custom dashboards, and it'll also appear on my strategic group summary page if I want to look at it that way. So as that data gets collected, those will get populated onto that system, and I can very quickly go in and see exactly, what's part of a particular application if I want to, or drill down into a particular, application grouping to see the status of the individual systems in that grouping. I can then, if I want, I can also make a rule that will automatically move those servers into that strategic group as well. So I don't have to manually create those groups once I decide what I want that to look like. One of the other things we talked about was the configuration management, and OmniCenter builds in a lot of configuration management tools. Um, in addition to your basic configuration management functionality to do things like notify if a configuration hasn't been saved, or to go in and compare and archive previous configurations. So I can go in here and kind of in real time compare a current configuration with any previous version of the configuration, and see exactly what's changed between those versions. And it'll pull up a report that highlights exactly all of the different new commands that have been added or deleted from that device over that time period. This particular example is a Cisco server, but the configuration management is specifically designed to be platform independent. It'll work on many different configuration formats, including things like Palo Alto style, C style, Linux configuration style. So if I want to use this to manage my hdb.conf file or a particular SQL.conf file on a Linux server, I can do that as well and have those changes flagged and alerted. And we can collect those configurations via SSH, Telnet, or other types of command line functionality. I can then also use the configuration management tools to execute commands on the devices in real time. So we actually have a web-based SSH client that can link directly into the device. It'll actually log me into the device and allow me to execute commands in real time if I've got the permissions in OmniCenter to do so. So I can run a command and have the response returned directly back out to the web interface. It'll then log exactly what commands I ran and when and who ran them. So I've got a perfect audit trail of exactly what was going on for those systems over time. So if I want to be able to go in and say, this particular system, what got changed at a particular time of day or a particular user, I can go in and see all the different commands that got run by that user, as well as the results of those commands. And we'll archive all of that data as well in the console session history for those devices. So it's a powerful tool to be able to allow you to centralize and log all of that information. I can also then, of course, send configuration alerts. We do that using a specific type of incident management rule. And incident management rules allow you to create more complicated if-then scenarios for when to send alarms, what kinds of alarms to send, and where to send them. But the configuration change alert is a very basic one where I can go in and say, what I really want to do is change who gets notified by this particular alert and what I want that alert to look at. So then I can pick a different grouping if I want to send that alarm to. Or I can even add additional groups and have multiple alarms sent out for a particular configuration if I want to make sure that gets copied to a distribution list, so my change control folks can review it at the end of the month. I can easily do that. So now I'd like to take just 1 minute to talk about who we are. For those of you who haven't worked with us before, Netreo is in the middle of our 20th year in business, and we've been profitable since year one, providing easy to use and comprehensive network management systems for both private and public enterprises around the world. We won Monitoring Product of the Year from Network Computing UK 3 years running and are nominated again this year. And we made the Inc. list of fastest growing companies for the last 2 years as well. Last year, after 18 successful years of being internally funded, we did a private equity transaction to gain additional working capital and resources, as well as access to some very experienced business experts, allowing us to grow even faster. And our track record in enterprise business really speaks for itself, with customers like Wells Fargo, Aon, Partners Healthcare, SpaceX, and many others, with whom we've maintained more than 95% customer retention since day one. Now I'd like to take just a minute and answer the remaining questions that we have here. Please enter them into the GoToWebinar interface if you haven't already. And I'm going to go ahead and launch a poll now. So if anyone would like us to follow up with additional information or discuss their unique environment, you can let us know that way, and it'll quickly let us get back to you. So the first question is, how is OmniCenter priced, and is there a charge for different kinds of monitors? So again, good question. OmniCenter is priced by device. So it's designed so that one device is one license, regardless of whether it's monitoring, 200 running processes, 15 drives, and 5 interfaces, or whether it's monitoring a remote site router with 2 ports. It's all just one device license model. So it's designed to be very simple for customers to be able to kind of estimate exactly what they're going to need and not get out of control like a lot of systems where they're charging you for each individual monitor, which is discouraging you from doing the kind of in-depth multi-level monitoring that's really going to make it effective in your environment. Next question is, have systems in an isolated DMZ, and how can I monitor them without creating multiple openings in the firewall? So just this last year, we actually introduced a technology called the remote polling lander. And the idea is that it can be installed as a virtual machine or as a physical box in a DMZ, and it can do all of the data collection locally and then pass that information back to OmniCenter over a single encrypted HTTPS connection. So it will actually act as a remote data collector in those cases, and it was specifically designed for the use case where you've got like an isolated, virtual data center in a cloud provider, for example, or an isolated segment where you need to be able to collect data in visibility, but you really can't have unlimited access for all the different types of application checks and system checks and OS level checks that you want to be running going through the firewall. So that gives you a really good way to do that. Okay. So thanks everyone for joining us today. I hope you picked up some useful tips to improve and simplify your network and systems management. And as always, if you have any additional questions, please feel free to contact us at info@netreo.com, and we'll be sure to get back to you right away. Have a great rest of your day, everyone.